Hi folks, this video is going to be talking about how to come up with an equation given a sinusoidal graph. So while we're looking at a graph that looks something like this, we are going to have the ability at the end to come up with an equation being something that's like y equals, it'll have sine or cosine in it, and it'll have numbers all around, maybe brackets, that if you were to type that into Desmos, or if you were to graph it using graphing paper, you would come up with that same picture or graph that you had just looked at. Okay, so we're going to figure out how to do that in this video. But before we can do that, we have to be really familiar with what we see right here. If you don't like seeing the f at x part there, the function notation, which we've talked about in other videos, all you have to do is just pretend that's a big Y there, okay? Now, let's go through these variables here. So we have the a here in the front of this equation, and just to review, the a is our amplitude, okay? If it's negative, it will flip. It'll flip whatever function you're talking about. It'll flip that graph upside down, okay? In this case, it's a curve, so it would flip the curve upside down. I guess I don't need to draw that. You know what I mean. Okay. The equations today are either going to have sine or cosine in them. Okay, sine and cosine we know both are like a wave. They're a periodic curve, sometimes known as sinusoidal curves, and so just sine and cosine will be used today. Okay. Speaking of k, I just said k. K is this value right here. Now that value relates to the period, and the way you do it is, well, here's that formula we learned in the last video. Period equals 360 degrees divided by k. K is the number or the value that goes right here. So if we know the period was, let's say, 180 degrees, if we're looking at a graph and we see that the period is 180 degrees, all we have to do is go 360 divided by k. The value for k will be whatever k is when we solve for it here. Okay, in this case 360 divided by k would be 180. Well, we know k would be excuse me, k would be 2. So 2 would be the number that would go right there. Okay, we'll be doing that in the examples today. Now x is always here. However, the minus d part, well, you have to remember that when you have a minus sign and a number here, it's going to do the opposite of what you think. What's inside the brackets here is the left and the right, or phase shift part of the graph, and it'll move the opposite of what you think. So if there's a minus 5 here, it's actually going to go to the right 5, and if there's a plus 5 here, it's going to go to the left 5. Okay? So the amplitude is the distance, as you might recall. I'll do it in red. It's the distance from the axis of the curve to the top, or the axis of the curve to the bottom. Okay, so in other words, the amplitude is going to be here. It's just going to be 1. So the amplitude is 1. So we know this number here is going to be 1, which is basically invisible. The period, okay, we just talked about that on the other page. Okay, the period, remember the little formula. Period is 360 over k. So in this case, we have to first find out what is the period, and let's look here carefully. Let's say our curve started here, and it would go across, and when would it start over again? Right about here. Okay, it starts to go downhill right here again. Okay, so that distance is 180. Wow, that looks familiar. We just finished doing a question like this. The way you could solve for this is if you know about the Zorro method or cross multiplication, you could put a 1 under here and say 1, start at the k. 1 times 360 divided by 180. That quickly will tell you that k is 2. Or you can use whatever method you like. But k is going to be 2 because 360 divided by 2 is definitely 180. Okay? So I'm going to erase that stuff. And we know that k is 2. All right? The phase shift is the horizontal shift. Now this is something new. We haven't really talked about this yet, but would you agree that a cosine curve, I wish I could find my eraser here. There it is. There we go. Let's just erase a few things here. A cosine curve starts at the 1 here, and it moves down. And we can see that this is basically just similar to a cosine curve where it starts at the 1 and moves down. So in this case, if we're talking about cosine, remember cosine starts at an extreme. What do I mean by cosine starts at an extreme? It means that cosine starts either at the very top or the very bottom. How would you make cosine start at the very bottom? Well, if we had a negative sign, like in front of the amplitude, if we put a negative sign there, that would flip this thing upside down. So we'd be starting at an extreme bottom and working our way upwards. Exactly the opposite of what we see here. In this case, cosine starts at the extreme top, so that's like a positive cosine. And it's starting right here. If this curve had started, let's say, over here and made its way down, we could say that if we're using cosine, that it moved to the right 30 degrees. Okay, but in this case, it's starting right here where cosine usually starts, on the y-axis anyway. And so yeah, there is no horizontal shift here. Okay, so none. There's no horizontal shift at all. So let's write our equation now. It's going to be y equals. Now remember, we have 1 here. We have k is going to be 2, right? So k is going to be 2. And there's no horizontal shift at all. And there's also no vertical shift, up or down. So let's write this out as our equation. Y equals, amplitude is 1, so I'm just leaving that blank. It's cosine. I know this one here says sine, but we're going to use cosine because cosine starts at an extreme. Okay, so cosine, and remember 2 is k, is what we found for k. That goes right there. Then we have x, very important. And we could say plus 0, but there's no need for that because the vertical shift is 0, which means that there's no shift at all, up or down. So we just leave it. Oops, this thing is not allowing me just to have the 0 removed. There we go. Here is our equation. If we were to use Desmos and graph this in Desmos, we would come up with this exact situation here, okay? So it's basically a regular cosine curve, and the only difference is that the period is 180 instead of the usual 360. So the period, or the frequency of this period, it repeats itself twice as many times. It's twice what the regular cosine would be for the period. Okay, let's look over here. Axis of the curve. All right. Again, the axis of the curve, the way to find it, because this one's a little bit difficult, we could guess. I think it would be somewhere around here. But instead of just guessing, let's use our little formula. Take the maximum plus the minimum, which is -3. So 1 plus -3. And then we're going to divide by 2. So 1 plus -3, and then we'll divide by 2 after. So that's -2 divided by 2. So the axis of symmetry is -1, which is right here. And it's kind of nice to draw this line in, actually. I'll just draw it in. I'm not good at these dotted lines. Here. Now it looks like I made a dotted line again. There we go. And the amplitude, see, it's nice to have this drawn in because now you can see that the amplitude is the distance between the axis of the curve and the top of the line, or axis of the curve to the bottom. No matter what, the amplitude is always positive. If we put a negative sign, it just means we flipped this thing. But let's just figure it out. You looking at the graph here. From -1 to 1, how many is that? What is that amplitude? Remember, amplitude's always positive. So 1, 2. It's 2. The amplitude is 2. 1, 2. Or 1, 2. What's the period? Well, we have to find k here. So the period, when does this thing repeat itself? Wow, this one's a little tougher because it's hard to see the start and the stop of this thing. Wow. So let's look. Where's a good place to start here? I know this is halfway. 360 is going to be halfway because it's going to be another 360 before it comes back up. But we can't see it on the graph here. So I can guess that the period's going to be 720. Let's also see if it makes sense to look from 540 to, boy, this is not really well done. This would be about 180 right here. This spot right here, and that's the lowest point there. That would be around 180. So 180 plus 540, 540 plus 180, what is that, folks? I'm just showing you the old-fashioned. Look at that. It's exactly what we had predicted it would be. The period is going to be 720 degrees. It wasn't easy to see on this particular graph because there wasn't a lot showing, but half of it would have been 360. So I know that two of these lines right here would have made 720. So the period is 720. Now remember, we're not quite done here. You can't stick 720 in the equation. 720 is our period, and that's 360 divided by k. Okay? So if you were to go, if you were to solve this using whatever method you liked, you end up getting 360 divided by 720. So you end up getting k is equal to 1/2. Okay? So 360 divided by 720 is 1/2. I just don't have a lot of room here to do that. Hopefully that makes sense to you. But 1/2 is going to be the value that we put for k in our equation. Okay? The phase shift is the horizontal shift. Now, see this axis of the curve right here? Do you see how the curve on the y-axis is starting from the middle and making its way up? And then it makes its way down. If it starts at the middle and it's moving upward, that is how sine behaves, okay? So if this curve had started somewhere over here, like right over here, and made its way upward, if we were talking about sine, we would say it shifted to the right 90 degrees. But in this case, we're going to say it didn't shift at all if we use sine. Now you might be asking, what if we had chosen cosine? Well, remember, cosine starts at extremes, so right up here. So if we were talking about cosine here, we would say, well, cosine normally starts right here on the y-axis and then moves downward. So this time we would say cosine started at 180 degrees, which means the whole thing shifted over 180 degrees to the right if we were doing an equation using cosine. But in this case, we're going to keep with the most simple option, which is just stick with sine. And sine is not moving left or right, so there's no horizontal shift. Okay, there's none. So at this point, let's write our equation. Let's write it in yellow here. So y equals, first of all, the amplitude's 2. That's the very first thing you write down. We're choosing to use sine as our option this time between sine and cosine because of how it started on the y-axis like this. So we're going to use sine this time. And if it were moving downwards here, by the way, folks, what would we do? What if this was moving downwards right here, right in the middle? We would just put a negative sign in front. So 2 sine. Now what is k? 1/2. Don't forget the x. And do we have a horizontal shift? We do not. Otherwise we'd have to put brackets here. But we do not have one, so I'm not going to put brackets. The axis of the curve is -1, so you're going to write that on the end. And that is the answer that we could check by punching that into Desmos, and you could see that this is graphed correctly. So I hope that helps. Oh wow, we do have one more question here. So let's go for it. And this question is going to be interesting. Let's do it. Axis of symmetry. Well, I can see on here that it's right here. Just visually, I can tell this is in the middle. It's splitting this thing in half. If you didn't see that readily, you would just take 2 plus 0, which is 2, and divide by 2, you would get 1. Okay, so the axis of symmetry is 1. The amplitude, well, if that's our axis of symmetry, the amplitude's the distance from here to here, or from here to here, and that is 1. The period is 360 divided by k. So in this case, period here is, this one's going to be no problem. We could say, let's start here and say it's this distance from here till here. It's where the graph starts to repeat itself. So between 210 and 30. So what's 210 minus 30? That will give us our period. Okay, think about it for a second, and you should get 180 degrees. See if that makes sense. Is it 180 degrees to go from here till here? It is. 180 degrees. So now we have to find k. So 180 is our period. 360 over k. And again, it's very similar to the first question. It's going to be k is equal to 2. Okay? That's what k will be, just like the first question we did, if you want to go back and look why. Okay, the phase shift. Okay, I like looking at this without having writing all over it. We just want to see this thing as it is. Here we go. Good. Okay, so here's the axis of the curve, or the axis. Whoa, it's supposed to say axis of the curve. I forgot to change that. It took me this long to realize it wasn't done properly. I hope that didn't distract you. The axis of the curve is right here. If we were talking about sine, then we'd say it started either here or right here. I'll use red. If we were using sine, we'd say it started there or there, and say how far left or right did it go from this y-axis right here. I think in this case it would be easier to talk about cosine. Cosine starts from the top, moves down. It starts at an extreme and moves down. Okay? So can you all see that cosine, if we choose cosine, then we'd say that this particular graph has moved 30 degrees to the right. Cosine normally starts at the extreme right here on the y-axis and moves down. This one has started 30 degrees over to the right. Okay? So the phase shift is 30 degrees to the right. All right? So now what we're going to do is we have enough information here to write down our final answer. This time we're going to use cosine. Start with the amplitude. It was 1. So I'm going to leave that. Remember, we thought that cosine will be the best choice here. Remember, if cosine's moving downwards, we don't need a negative sign in front of it. If cosine had started down here and moved upwards, we would need a negative sign there. Now next is k. K is right there, 2. Then we have x. Now be careful because there is a shift 30 degrees to the right. You're going to need brackets here. Okay, 30 degrees to the right, be careful. It's not a plus sign like you might think. It's always the opposite of what you think. So it's going to be x minus 30. The brackets always lie to us. And the axis of the curve, which goes on the very end, is 1. And here we have our equation that best suits this sinusoidal curve right here. This time I know it's the last question, so I'm going to sign off because this video is probably getting a little too long and I'm afraid you're falling asleep. There may be more videos related to this stuff in the near future. Take care.